Welcome to homework.
Okay, so we're talking about benzene. Right. And essentially what we're saying is that we can draw the pi orbitals for benzene and then predict, what the bonding and anti-bonding orbitals would be, as well as depict their nodal planes and label their energies in terms of alpha and beta. So what we're going to do to represent the orbitals is that we can simply draw a six-membered ring, right? And then if we wanted to draw, for example, the lowest energy orbital in which every p orbital is the same sign, simply draw them all in black. And this would be the lowest energy orbital, right? And so this would have then the energy of alpha plus 2 beta, right? And then we could additionally say, okay, so this has no planes, so we've got no planes to depict, right? Everything's the same sign, but in contrast, we could draw, there's two ways that we can draw this in which we have a single plane, right? So we could say, okay, everything up top is one sign, and then we'll use red for the other sign. Okay, and then our nodal plane then would separate the top from the bottom. Okay. Likewise, we can have a nodal plane which passes through two atoms, right? So in that case, we would have two p orbitals here, two p orbitals here, and then a nodal plane that passes through these two atoms, so no contribution from these atoms. Okay, so then the energy would be simply alpha plus beta. Okay, next we can draw the antibonding orbitals. So these would have two planes, for example. Here's one version in which the planes do not pass through any atoms. Okay. And we can draw another set of orbitals with two planes. Now, our planes, one of them would pass through these atoms, which have no contribution, and one would pass through this way. So these would both have the energy alpha minus beta. And finally, we can draw the three-plane version, of which there's a single molecular orbital. And then in this case, it's just alternating every single atom. Effectively just like individual p orbitals. With three planes as such. And the energy here would be alpha minus 2 beta. And then recall that the energy, if you wanted to, give, say, the energy of, if I put two electrons into this lowest energy orbital, that it would be energy equals negative 2 times alpha plus 2 beta, right? So these are effectively the magnitudes of the energies, but the energies themselves, or the energy of putting an electron in there, would be negative. But typically we depict it like this. You could also say negative alpha minus 2 beta. Either of these would be fair ways of representing the energy of this orbital. Either with the understanding that this positive number will eventually be negated when you put electrons into it, or just by drawing it as negative alpha minus 2 beta. This would be, negative alpha minus beta. This would be negative alpha plus beta. And you could depict this final one again as negative alpha plus 2 beta, depending on how you've been shown to do it.